in your book to page 96. And in page 96, there's really not one way to do it. And on some of these, there are multiple answers that work. As long as your answers fit the description, then that's good enough for me. We do need to talk about something, and it's certain types of symmetry. So if I have a graph that looks like this, so if I have this graph and pretend that I could draw it better than I did, this is symmetric across this line. If I were to fold it across that line, and if I were a better artist, then the left side and the right side would be exactly the same. So in this assignment, it talks about even functions and odd functions. We're going to get in a little bit into even that, but not too much. Really, we're just going to worry about symmetry. So an even function says, if you take f of negative x, so if you look at the equation, for every x, you changed it to negative x, and you looked at the equation, it's going to equal exactly what we had before. So this is, anyway, so here's the principle. Well, f of x is equal to x squared. What's the difference between x squared and negative x squared? They're the same. In polynomial form, if all of your exponents are even numbers, it's an even function. Now, sometimes a lot of polynomials that are even factorize and still return x. There are other even functions that are even functions. So if you have like x to the 6 plus 2x to the 5 and then x squared with a constant, then it would be an even function. And an even function is metric about the y-axis. So any function that's metric about the y-axis is an even function, and that's the attribute we're going to use today. So if I have an even function, and I know that this is a root, and that this is a point, what do I also know? On the other side, I have a root here and a point there, because it's an even function. Okay? Odd function is a little bit harder. An odd function, you can't negative x, that's exactly the same thing as negative f of x. For instance, if my function x to the third plus 2x, okay, if I change the sign on the x's, I have negative x to the third plus 2 times negative x. Is that the same thing as changing the signs on the outsides? Is that the same as negative x to the third minus 2x? Well, it actually is. So I can move a negative inside and out of a third power. Not a square, but a third power I can. This negative, notice all of my exponents are odd. I had the third plus 2x squared. Make this negative, swap negative x to the third. Make this negative, I have squared plus negative x squared. Is this opposite? Or well, an odd metric about then it's trick. And you keep drawing that line in the of point. Instead of holding off, and if you have a polynomial and all of right. Number one, okay, to fold it across the y-axis. Linear. Negative infinity to this mark, it's going down. Like that. But I don't know how high and low it is yet. So if it's going down on the left side and it's an even function, what do I know about the other side? It's got to be going up because it needs to reflect this. Okay? It has a minimum point at 0, -3. So this is minimum, and it also touches point 2, 0. Well, if it touches 2, 0, it must also touch -2, 0. So that would be the function. That's it. Yeah. Both of them have multiple answers. Yeah. Okay. E of x periodic. What does that mean? It's a wave function, like a sine curve. Periodic means it goes up and down in a period. Period meaning the length it takes to go up and down. Okay? It's periodic, and it's odd. So a wave function, I'll bring my graph over. If it was right here, that would be an even function, because if I fold it, it matches. If it was centered right there, it would be an even function. Where would I put it to be an odd function? Either there or there, and that would be symmetric about the origin. Well, sorry, I mean there. So there or there. Okay? That has x-intercept at 0 and f at plus. This is kind of confusing. So I'm going to touch 0, 0, and then how often am I going to touch from then on? Every 4. So I go over to 4, and there would be 1, and over to 8, there would be 1, and -4, and -8, and so on. Okay? It has a maximum at 2, 3. So 2, 3 has a maximum, and a minimum at 6, -3. So 6, -3. So what is this graph going to look like? Well, it's periodic, so it's going to be a wave. It's going to start at 0, 0 and go up to the max. It has to hit the x-axis again, and it's just going to continue doing that same pattern over and over. It's really an odd function. does work. Okay. Scratch that. Okay. You guys want to try one on your own? No? Not yet? Um, yeah. H of x is a function with a maximum value of 1, 9. Now, they didn't tell us if it's absolute or if it's relative. So it could be not a true maximum. It's just a high point. Or, okay, this point, they didn't tell us. So I need to figure that out from the rest of this. So a maximum at 1, 9. So 1, 9 is a maximum. It has intercepts at negative 2, 0, and at 4, 0, and end behavior. As x approaches infinity, h of x approaches negative infinity. What does that mean? What does x approaches infinity tell me? To the right. As x goes to the right, the graph is going down. So I know that this end behavior is that direction. Okay? And x goes to the infinity, so that's to the left. As x goes to the left, h of x goes down. So this also, can we draw a graph that fits that description? Yeah, a parabola would work. Is that the only graph that fits that description? Oh no, not even close. So you could have all sorts of wiggling going on, and lots of answers for that one. Okay. All right, number 4. I haven't taught you yet, but it's good to know because you're going to use it in calculus for sure a lot. Okay. So j of x is a function with intercepts at negative 1, 0, at 0, 3, okay, and it passes through the point 3, 7, so it goes through that point, is number 4. And this I understand. As x goes to infinity, that means which direction as x approaches infinity? The right. As x goes to the right, then h of x goes up. So this side is up. Now, the rest of that's a little, as x approaches negative 2, positive. What that means is as x approaches negative 2 from the positive side of the axis, which means from the right. Okay, what? So this says as I approach negative 2 from the right side, not the left side, the right side, it goes down. So it's got to go through there and it's got to go down. That's what the graph would look like. Right, right. That's the graph of it. Okay? What? This is a vertical asymptote, right? What happens on the other side of that vertical asymptote? X approaches negative 2. X approaches negative. Well, actually, negative.